Yehuda, Jian, thank you so much for coming on to the Lifted podcast. How are you today?
I'm good. Thank you for having me.
Oh, absolutely. So I have some questions I want to ask about very quickly some stuff that are going on in our outer space above us. What the hell is going up there? I don't understand how there can be an empty space of blackness and darkness above us that we're just floating on. Please explain this entire world to me, please.
Beginning of time, Big Bang. So the Big Bang was basically a bunch of concentrated energy that kind of just went boom. And we're talking all of this in like less than a second here. We have different particles popping in and out of existence in this like primordial soup. As things spread out, the universe, which is still very small at the time, rapidly starts to cool. We're talking like micrometers here.
Okay.
So as the universe cools, it becomes cold enough for particles to start sticking to each other. Protons, neutrons. Eventually, you get the first atom, which was hydrogen. As things cool down more, you get bigger clumps of particles, and that's where you move along the periodic table. Then you start getting heavier things. Atoms start coming together. You start getting molecules. Eventually, you get dust. The dust coagulates into space rocks. Some of it gets so condensed that it spontaneously combusts into stars. And I'm skipping a lot here.
So we look up, we see a blue sky. That could be as a result of whatever the atmosphere. Is that what it's?
Yes, because the most powerful wavelength is blue. So everything else gets absorbed, and what we see is blue.
What we see is blue. Then you look far away, 13.8 billion light years away, and then you see practically the edge of our observable universe, I guess you would call it, right?
Sure.
What is 1 light year ahead of that? What is that darkness?
There's lots of theories about it. I can tell you that there is one theory that thinks that our universe is one of multiple, or endless, in fact, that are exactly like it, and they're all expanding in nothingness at the same time, and eventually they'll crash into each other, and when they do, that creates a new Big Bang. That's one theory.
Multiple universes?
Yes, but saying that the universe has an edge is a little tricky, because it's not like a flat circle that you can go from the middle to the outside of. It's also not a perfect sphere. There is one theory that says it looks something kind of like this. I don't know what you would call that shape, but it's curved, wider on the top and bottom, and a little bit narrower in the middle.
And they're saying that they think that our universe is shaped in that way.
One theory.
One theory. Wow.
Let's say we're looking at something that's 100 light years away, but it's entirely possible that that thing just no longer exists. And we don't know yet, because the change in the light that it's putting out hasn't gotten here yet.
So you're saying it's possible that we're looking at stars that no longer are there?
Yes, it's very possible.
Wow. What is the word dark matter, or does that have anything to do with our discussion right now? Dark matter.
Right. So there's dark matter and there's also dark energy. We're calling it that because it's just a description for the phenomenon that we see. And basically what we see is, if you add up all of the observable matter in the universe, it only makes up for 4% of the amount of gravity that should be happening.
If you add up all the matter in the observable universe,
it doesn't generate enough gravity to make the laws that we know are true make sense. So there's a massive amount of something out there that helps it out. Basically, at the center of almost every galaxy, or at least every galaxy that looks like ours, there's a black hole. That's what makes them spin.
At the center of
the arms,
the galaxy. Oh,
yeah, there's a black hole.
So we are also in a galaxy.
Yeah, no.
Are we going in a black hole right now?
Yeah. The solar system is really, really small, and it's fairly far away from the middle.
We are spiraling down a black hole right now.
We're not in a black hole. We're orbiting around a black hole.
Right. I mean, right. Wow. Okay.
Let's just say the sun will probably go out before we get to that black hole. And even before the sun goes out, the Earth will probably burn, because the sun will become a red giant.
What's red giant? It becomes very
red
massive.
Giant is a type of star. It's one of the later stages of stars. Our sun is relatively young as far as stars go. Stars are basically like infinite nuclear bombs going off. They're basically just fusing atoms together and ripping them apart inside their core. That's what keeps them burning.
That's crazy.
Yeah.
It's like that much energy is being produced basically.
Yeah, but think by the order of millions of these things going off in the core of the star every second. Eventually, they run out of fuel. Eventually, the atoms get so heavy that the star implodes on itself because it's too heavy. Imagine a balloon, right? And you're slowly taping sand onto the outside of this balloon.
Okay.
Now, one layer of sand that's 1 grain thick is not going to do anything.
Right.
And you keep piling stuff up on the outside of this balloon, eventually it's going to collapse.
Right. Okay. But from the inside, in that case, for stars.
Yeah,
So you have a solar system. You have a solar system with the sun obviously is at the
yeah.
center. You have Mercury, Venus, Earth, Mars, Jupiter, Saturn. What else am I missing?
Uranus,
Uranus and
Neptune.
Neptune. And would you consider Pluto a planet these days, or
No, we do not consider
we don't?
Pluto a
Okay.
planet.
Okay.
It's basically a very large rock that fell out of the
Okay, so we
asteroid belt.
have 9 planets in our solar system, and we're all spiraling around a sun, and that sun itself, and the
Is
solar system
going.
itself, is revolving around a black hole. You're saying?
There's another type of system that's in between solar systems and galaxies. I don't remember what they're called, but the sun is part of that, and then that is going around is part of the galaxy, and the entire galaxy is spinning around
So if
a black
time went
hole.
on for long enough, we would eventually be sucked into this black hole that's at the center of our galaxy.
Yes, theoretically. A black hole is basically just super compacted matter to the point that the gravitational pull is so powerful that light cannot escape. Light is the fastest moving thing that we know of. Black holes have like this little rim around them that's white. And the reason that is because that's all the light that's getting pulled in. That's the last point where it can escape. Anything that gets
How
further than that, anything that gets further than that white thing, even moving at the speed of light, will not help you get out of there. The amount of gravity pulling you is just so insane. Imagine 3 billion suns.
3 billion suns. Okay, of our
Yes.
suns. Okay.
Mhm.
Three. I can't even fathom that number. I mean,
Right. It has the weight of 3 billion suns in a size that's definitely not the size of 3 billion suns. It's a lot
right.
smaller than that.
Wow.
You know how some materials are denser than others and you can feel it because one is heavier even if they're the same
Right.
size?
Right.
Imagine that and apply it on a supermassive scale.
So why do we hear talk about black holes being a possible teleportation device? Is that just total?
Because we have no idea what's on the other side.
Oh, okay.
So there's a lot of talk about where does all the stuff that gets sucked in there go?
Interesting. Interesting.
Assuming that there is an out somewhere in black holes, there is this theory of light holes.
Of light holes?
White holes. They're called white holes simply because they're supposed to be the opposite of black holes, where they just basically spit out matter.
Oh wow, white holes. Okay.
There's no proof of them. This is just a theory. My personal opinion,
Wow.
and this is not founded by anything. My personal opinion is that if someone tried to enter a black hole, they would be crushed into an insignificant speck of dust before they ever got to the other side. Because again, we can't send anything in there
Right, because
that will survive.
right.
At least, like, unless we figure out some super awesome suit of armor that protects you from the gravity of a black hole. I have no idea how that would work.
And they're doing research, of course, to find
Yeah.
out more about this stuff.
We do as much research as we can, but really all we can do right now is look at it.
So why do I keep hearing physicists and scientists comparing time and space as if they're like the same thing?
They're not okay. So time is not exactly what you think it is.
Okay.
As far as physics is concerned, like you can talk about time philosophically, or you can talk about time in the sense of religion, but as far as physics is concerned, space and time are connected around things that are heavy enough, such as black holes.
Okay.
Time works differently.
Time works differently.
Yeah. So
Okay.
a black hole is so heavy that it actually distorts time immediately around in the space immediately around it.
Wow.
We're far away enough that we're not getting immediately affected.
I don't want to be mistaken, but I'm pretty sure I watched a video. Neil deGrasse Tyson was talking, and he was saying that the closer you get to the black hole, the slower and slower you perceive that person to be going, but in reality, he is going faster.
Yeah, so things are definitely moving faster.
Right.
When things around you seem slower, that means that you're moving faster.
So based on that theory, then, if I were to witness from somehow, I'm obviously we're too far away to be able to experience this, but if I were somehow able to see a human being or an object entering a black hole, from the perspective of me on Earth, that item or that person would be going at a very, very slow rate of speed. Whereas if that object, or that human being rather, had a consciousness, he would be perceiving his time in a
As moving
totally more
super fast.
super quickly. Wow, wow.
And
Wow.
so
Fascinating.
we can actually see things enter black holes.
We
Because
can?
we have telescopes that can see black holes, and if you can see a black hole, then you can see what's immediately around it. So we
Right.
can watch things go in.
Wow, I would love to see a video of that, actually.
You'd need to pay a lot of money to get your hands on that information. The way time zones work is basically the Earth is spinning around on itself.
Okay.
It's not just orbiting around the sun. The orbit around the sun is what decides years, and the Earth spinning on its own axis is what decides night and day.
Got you. And what causes there to be that proportion of day and night?
There's always half of the Earth that's facing away from the sun.
So that's moving
So
constantly.
we call it 3 p.m. here because that's what helps us make sense. If everywhere ran on the same clock, then 8 a.m. here would be 8 in the morning in Israel, but it wouldn't be morning for them.
So we have 24 hours in a day, right?
We arbitrarily split up that time into 24 60-minute periods.
24 60-minute periods. And does
Called
it have
hours.
does it have to be that way?
No, we could do 3 hours in a day, and each hour would be however many minutes.
Each spot on the earth gets an equal amount of sunlight and equal amount of night, I guess. Lack of sunlight, right?
No, that's only along the same latitude.
Oh, right, because at the north and south poles you don't have.
Right, and also it's not just that; it's also that Earth is not like this. It's on an axis a little bit. During what we call winter, the reason it's summer for the southern hemisphere is because that's when this part of the Earth is facing the sun and this part of the Earth is facing away from the sun. But when you circle around, you're on the other side, then this part of the Earth is facing towards the sun. This part of the Earth is facing away from the sun.
Interesting.
So during our summer, this half gets more sunlight, and then during our winter, this half gets more sunlight.
So our Earth is spinning, correct?
Yes.
And what's causing that to spin?
I'm not entirely sure, but I imagine it has something to do with the origins of the Earth, which was basically a bunch of rocks hitting each other.
And the Earth is also rotating around a sun.
The sun, yes.
And then the moon to us is just a chunk of mass that has come off of some asteroid belt. Where did that moon come from?
The moon actually broke off of the Earth.
The moon was part of the Earth?
Yes.
The moon was part of the Earth and it broke off. How did it break off?
Billions of years ago, something crashed into the Earth. It split into two pieces. And
if we were to be on Mars, it would no longer be called the moon because we would have.
No, it would be called the moon of Earth.
The moon of Earth. And then in Mars, we would have a different type of moon. Do we have a moon on Mars?
I think it does. I'm not 100% sure. I know that Jupiter has hundreds of them.
So then we would have to specify what we're talking about.
Yes, which is why they come up with names for every rock that they find. There is a name for every asteroid that we've seen in the asteroid belt.
Seems to be very knowledgeable in these types of subjects, so that's very interesting. I hope to have you back on the show again to talk about some other interesting, fascinating concepts like this.
Yeah, it was a lot of fun.
Absolutely. Thank you so much.
Thank you.